two metallic sphere of radii 1 centimeter. So R1 equals to 1 centimeter, 1 into 10 raised to minus 2 meters, and second one 3 centimeter, 3 into 10 raised to minus 2 meters. Are given charges Q1 is equals to minus 1 into 10 raised to minus 2 coulombs, and Q2 will be equals to 5 into 10 raised to minus 2 coulombs. If these are connected by a conducting wire, what will be the final charge? Now be careful, these are not point charges, these charges are spreaded over metallic spheres. If they were point charges, in that case I told you, you have to simply add Q1 plus Q2 divided by 2. Let me repeat, if they are simply point charges, you have to add Q1 plus Q2 whole divided by 2. But since they are not point charges, here these are conductors, and for these conductors first we have to find the capacitance values. Wait, what is the capacitance value for a spherical conductor? In this case, if you don't know, this is C is equals to 4 pi epsilon naught R. Let me repeat, this is the capacitance value for spherical conductors. Spherical conductors. This they have omitted this here, okay. But since it's a competitive exam, they can ask you anything. So C is equals to 4 pi epsilon naught R. So what will be the concept here? If two such metallic conductors are connected with each other, then their net capacitance, okay, will be C1 plus C2, and they will come to a common potential. That is very, very important concept. When two such conductors, they are connected with the same conducting wire, then they will have a common potential. And what will be the common potential? Let's figure it out. So common potential will be V, that will be equals to the total charge upon total capacitance. So Q1 plus Q2 whole divided by C1 plus C2. Let me repeat, the common potential of such a system will be Q1 plus Q2 whole divided by C1 plus C2. So what is Q1 plus Q2? That will be minus 1 into 10 to the power minus 2 and plus 5 into 10 to the power minus 2 whole divided by 4 pi R1, 4 pi epsilon naught R1 plus 4 pi epsilon naught R2, right? So I am taking 4 pi epsilon naught common. R1 plus R2. R1 is what? 1 into 10 to the power minus 2 plus 3 into 10 to the power minus 2. Anyone has any doubt or not understood this part, speak up. V is your common potential, which is equals to Q1 plus Q2 upon C1 plus C2. Okay, let's figure out what is our V value. So 5 minus 1, 4 into 10 to the power minus 2 upon 4 pi epsilon naught. For the time being, I am just keeping it 4 pi epsilon naught. Maybe it will cancel out later, or otherwise we will keep the values, okay, into C1 plus C2, that's 4 into 10 to the power minus 2. So this will cancel out and we left with common potential as 1 by 4 pi epsilon naught. That's your common potential for this system. Now, the question is saying, if these are connecting by a conducting wire, what is the final charge on the bigger sphere? Bigger sphere means, this is obvious, they are asking for this R2. So the net charge, what is the charge value? The charge Q is equals to CV. So Q prime will be the new charge, that will be the capacitance. Now capacitance value doesn't change if you are connecting both of them with a common wire, because capacitance is the constant related to that conductor. So it will be R2 into common potential V. So what is your R2? 4 pi epsilon naught. R2 is 3 centimeters. So 3 into 10 to the power minus 2, and common potential is 1 by 4 pi epsilon naught. So this will cancel with this, and correct answer is 3 into 10 to the power minus 2 coulombs. So correct option is option B.